Hi, today we are going to discuss about the bond polarity and the dipole moment. At the end of this lesson, students should be able to explain bond dipole and dipole moment, and also deduce the polarity of molecules based on the shapes and the resultant dipole moment. What is exactly the bond dipole? Bond dipole can be defined as the separation of electric charge along a bond that leading to a molecule or its chemical group having an electric dipole or dipole moment. How can we measure the polarity of a chemical bond? In a covalent molecule, electrons are not always shared equally between two bonding atoms. One atom might exert greater pull on the electron cloud than the other. This pull is called electronegativity. The bond dipole moment occurs when there is a separation of positive and negative charges. In hydrogen fluoride molecule, the fluorine atom is more electronegative than the hydrogen atom. Therefore, the electrons are pulled towards the fluorine atom and creating a slightly negative charge region. While for hydrogen atom, the electrons are pulled away from the hydrogen atom towards the fluorine atoms and creating a slightly positively charged region. Electronegativity always increases toward fluorine atom in the periodic table. When atoms with high electronegativity values such as fluorine, oxygen, and nitrogen exert a greater pull on electrons, this can lead to unequal sharing of electrons between atoms, as electrons will be drawn closer to the atom with higher electronegativity. The unequal sharing of electrons within a bond leads to the formation of the electric dipole, which is a separation of positive and negative electric charge. Polar bond can be defined as a covalent bond between two atoms of different electronegativities in which electrons are shared unequally, this resulting in a bond in which one atom has a partially negative charge and other partially positive charge. In hydrogen chloride molecule, chlorine atom is more electronegative than hydrogen atom. Thus, chlorine atom has a greater pull on electrons. This will lead to the unequal sharing of electrons between the atoms. Therefore, the HCl bond is a polar bond. The nonpolar bond can be defined as a covalent bond between two atoms of same electronegativities in which electrons are shared equally. This resulting in a bond in which both bonded atom has no charges. In chlorine molecule, both of the chlorine atom has identical electronegativity. Thus, this will lead to the equal sharing of electrons between the atoms. Therefore, the Cl-Cl bond in chlorine molecule is a nonpolar bond. What is dipole moment? The dipole moment can be defined as the product of the magnitude of the charge and the distance that separates the center of the positive and the negative charge. Dipole moment is a measure of molecular polarity. When atoms in a molecule share electrons unequally, they create a dipole moment. This occurs when one atom is more electronegative than another, and resulting in that atom pulling more tightly on the shared pair of electrons. They are also known as a polar bond. Thus, the larger the difference in electronegativity, the larger the dipole moment. In a polyatomic molecule that contains polar bonds, the dipole moment is equal to the resultant dipole moment of all the individual bonds. The magnitude of the resultant dipole moment not only depends on the bond dipoles, but also their molecular geometry. If the dipole moments cancel each other, thus the molecule has no net dipole moment or equals to zero. If the bond dipoles do not cancel each other, thus the molecule has a net dipole moment or non-equals to zero. The dipole moment is a vector quantity that possesses both of magnitude and direction. Therefore, the dipole moment can be calculated using this formula. A molecule with a dipole moment that non-equals to zero can be classified as a polar molecule, while a molecule with a dipole moment that equals to zero is classified as a nonpolar molecule. The direction of polarity of a polar bond can be symbolized by a vector quantity. The cross end of the arrow is the positive end, and the arrowhead is the negative end. For example, the hydrogen chloride molecule. Chlorine atom is more electronegative than the hydrogen atom. Therefore, the vector quantity is showing from hydrogen to the chlorine atom. A vector quantity can also be zero, as the two oppositely acting bond dipoles can cancel each other. For example, in beryllium difluoride molecule. In this molecule, the fluorine atom is more electronegative than the beryllium atom. Thus, fluorine atom will having negatively charged and the beryllium with positively charged. In this molecule, the two bond dipoles cancel each other because they are equal in magnitude, but they are oppositely in direction. Therefore, the net dipole moment of the beryllium difluoride molecule is equal to zero. A polar molecule must contain polar bonds due to the different electronegativity between the bonded atoms. A polar molecule has a separation in charge, which is having a partial positive and partial negative charges. Thus, a polar molecule has a net dipole moment. For a nonpolar molecule, it contains nonpolar bonds due to the same electronegativity between the bonded atom. A nonpolar molecule has no separation in charge, so no positive or negative poles are formed. Therefore, a nonpolar molecule has no net dipole moment. How can a molecule contain polar bonds be a nonpolar molecule? In a polyatomic molecule that contains polar bonds, but the molecular geometry is symmetrically allowing the bond dipoles to cancel each other. For example, in boron trifluoride molecule, the bonds are arranged symmetrically in trigonal planar geometry. Therefore, the bond dipoles cancel each other and do not create a molecular dipole moment. How can we determine the polarity of a molecules? We can use these three simple steps. First, predict the molecular geometry. Next, determine the bond dipoles. And then, determine whether the bond dipoles can cancel each other or combine to produce a resultant dipole moment for the molecule. Let's consider for a few examples. The first example is boron trifluoride molecule. In this molecule consists of BF bond, which is a polar bond. The bonds are arranged symmetrically in trigonal planar. The bond dipoles can cancel each other, so the molecule has no net dipole moment or equals to zero. Thus, BF3 molecule is a nonpolar molecule. The second example is carbon dioxide molecule. In this molecule consists of CO bond, which is a polar bond. The bonds are arranged symmetrically in linear shape. Therefore, the bond dipoles can cancel each other. So the molecule has no net dipole moment or equals to 0. Therefore, the carbon dioxide molecule is a nonpolar molecule. The next example is tetrachloromethane molecule. In this molecule consists of CCl bond, which is a polar bonds. All the bonds are arranged symmetrically in tetrahedral. Thus, the bond dipoles can cancel each other and the molecule has no net dipole moment or equals to 0. Therefore, the CCl4 molecule is a nonpolar molecule. The next example is sulfur tetrafluoride. In this molecule consists of SF bonds, which is a polar bonds. All of these bonds are arranged symmetrically in square planar. Thus, the bond dipoles can cancel each other. That produces a molecule with no net dipole moment or equals to 0. Therefore, the SF4 molecule is a nonpolar molecule. The next example is hydrogen bromide molecule. In this molecule consists of HBr bond, which is a polar bond. The bonds are arranged unsymmetrically in linear shape. Therefore, the bond dipoles do not cancel each other and produce a resultant dipole. Thus, the molecule has the net dipole moment, which is non-equals to 0. Therefore, the HBr is a polar molecule. In sulfur dioxide molecule, each of the SO bond in the molecule is a polar bonds. Each of the bonds are arranged unsymmetrically in V shape. Thus, the bond dipoles do not cancel each other and combine to produce a resultant dipole moment. So, the molecule has a net dipole moment. Thus, SO2 molecule is a polar molecule. The next example is chloromethane molecule. In this molecule consists of CCl bond, which is a polar bond. The bonds are arranged unsymmetrically in tetrahedral. Therefore, the bond dipoles do not cancel each other and combine to produce a resultant dipole. So, the molecule has a net dipole moment and thus it can be classified as a polar molecule. The next example is ammonia molecule. In this molecule consists of NH bond, which is a polar bond. These bonds are arranged unsymmetrically in trigonal pyramidal. Thus, the bond dipole do not cancel each other but combine to produce a resultant dipole moment. The molecule has a net dipole moment which is equal to 0, thus ammonia can be classified as a polar molecule. Our last example is water molecule. In this molecule consists of OH bond, which is a polar bonds. All these bonds are arranged unsymmetrically in V shape. Thus, the bond dipole do not cancel each other but combine to produce a resultant dipole moment. The molecule has a net dipole moment, so water can be classified as a polar molecule. Let's try these questions. Determine the polarity of the following molecules. You can check your answer in tutorial video. Thank you.